Okay, I think we're back here. It cut me off, so I didn't make the 5 minutes. I don't know if anyone noticed, but I think on this slide I was like, I don't think I'm gonna make 5 minutes. So I was picking up the pace a little bit, but yeah, did not help it at all. I got cut off. Luckily, on slide 6 there's only 8, so we'll definitely make it through on this next one. So, like I said, in this type of mixture, homogeneous mixtures or solutions, it looks like it could be a pure substance, but it's just because things have dissolved so well in it that it just looks like that. And we know that things have dissolved well in it. So, that's what we get with homogeneous mixtures. So, you can almost tell by looking at it. Perfect example would be like Kool-Aid or something where it's just sugar and water and some food coloring in there. So there are some examples that are not just liquid and solid, where I keep talking about sugar dissolving into liquid. There's some kind of neat ones out here. So if I've got a solid and a solid solution, for example, brass. Brass is made up of zinc and copper, so they're melted down, mixed together. And so when you see brass, you'd be like, "Oh my goodness, is that an element?" No, it's the element zinc and element copper mixed together to make a homogeneous mixture. And sometimes there's some other things in there as well, but the zinc is dissolved into the copper. So you can also have liquid. So if you buy something like vinegar at the grocery store, you've got the acetic acid that's getting dissolved into the water, and you can actually get different percentages of acetic acid in your vinegar. So I think the most common one's 5%, but have a look at that next time you're looking at vinegar. 5%, 10%. There's probably lesser forms as well. And then gas and gas when they mix together. So air. Everyone always thinks it's oxygen, but for the most part, it's mostly made up of nitrogen. I forget exactly what it is, 71% or something like that, but mostly nitrogen, and then oxygen is mixed in there. So the solvent's nitrogen, and the solute in this case is oxygen because there's more. Usually, remember, it's the bigger one is usually the solvent. So that's air. So gas, gas, liquid, liquid, solid, solid, and they're all mixtures or solutions. And moving on to the next one, it's going to be the opposite of that. So when these ones all mix together, a heterogeneous mixture or mechanical mixture, it's given both names again, is a mixture where two or more substances can be clearly seen or felt. And a heterogeneous, hetero means different, genius means kind, so different kind. Homo meant same, hetero different. Mixture, the solute is not dissolved, or it can dissolve a little bit, but only partially. So some of the solute can be observed in its original form. And some easy examples of this are like granola, where you can see all the different parts, like the fruit is in it. It's not dissolved, it's just a mixture of things. Or cookies, here you can see the chocolate and all the different pieces of it. It's visible. Another one I put in here is soil. You've got the roots and rocks and everything that makes it up. So it's not a blend that sort of looks like one's solid, like it could be a pure substance. Heterogeneous mixtures, a mixture of things that you can like almost pick out, or you can just tell sometimes just by looking at it. And that brings us to our last slide here. Centuries ago, there were a whole bunch of scientists looking for this perfect solvent that would always dissolve everything, and they never quite came up with it. But the one that they kept using over and over and over again was water. So it's actually called the universal solvent these days. Um, One thing that I think I mentioned before, but it's very important to remember, just an easy way to remember which substance is the solvent and which is the solute. The solvent is the substance that is present in the greatest amount. So there's more solvent than solute. And oftentimes the solvent is water because many substances like sugar, that's the one we always go back to, dissolve easily in it, or salt. So water has been called the universal solvent. Um, However, other substances can be used as solvents. Ethanol and acetone are big ones. The solvent used in dry cleaning is not water. Just another little tidbit there that I thought was interesting. So again, water, the lifeblood of probably everything. It's sort of our life. You guys figured that out when we were doing ecosystems. There wasn't a lot of water in deserts, hence not very much life going on in deserts. Tons of water and moisture in the rainforest, and that's where we had the most life. So water is extremely important. Having said that, answer the questions at the bottom of this post, and you can always get in touch with me on Google Hangouts, or leave a comment or email me.